In this lesson, we're going to talk about the importance of detecting defenses during active reconnaissance so that later you can evade those defenses as you're moving into your attacks and exploitation phase. Now, there are a couple of key defenses that almost every network these days is going to use. This includes things like load balancers, firewalls, web application firewalls, and antivirus. Let's take a look at each of these and how you can detect them and then possibly avoid them. Now, the first thing we need to detect is whether or not the organization is using a load balancer. Now, a load balancer is not necessarily a security device, but it is something that can cause troubles for us as we're trying to scan, enumerate, and attack the network. So when we look at a load balancer, remember that a load balancer is a core networking solution that's going to be used to distribute traffic across multiple servers inside of a server farm. For example, if you're working with somebody who has a cloud-based network, and you start doing scans against it, and you're sending things into their network, going to a particular server, but they're using a load balancer, well, the first request might go to server A, and the second request might go to server B, and the third request goes to server C. And so you may be getting back different answers and different responses based upon what server is actually handling the request you sent. This is why it's important to understand if there is a load balancer or not. Now, from an operations perspective, load balancers are great for an organization, because they allow multiple servers to answer up as a single server. For example, on my site, we use a load balancer, and we have to do that because of the number of students that are visiting our site. A single server couldn't handle all of that load. Now, as you start scanning, you need to identify whether or not there is a load balancer. And one of the easiest ways to do this is by using a tool called LBD, or the Load Balancing Detector. This is an app you can use inside of Kali Linux. To use the Load Balancing Detector, simply enter LBD and the domain name you want to test. For example, if you enter LBD, diontraining.com, you'll be able to check if diontraining.com is using a load balancer. And as you can see here, we are using a load balancer. You can see that both by the DNS that is using a load balancing function, as well as our actual website itself, and it returns the 2 IP addresses that are found as part of our load balancing configuration. So why are load balancers so important to understand as you're doing your reconnaissance and enumeration? Well, it all goes back to scanning. If the organization is using a load balancer, it can really throw off your scan results and create a lot of false positives or false negatives for you. The next thing we need to discuss is firewalls. Now, if you think back to your earlier studies, you should remember that a firewall is a type of network security device that monitors and filters incoming and outgoing network traffic based upon the organization's established security policies. Normally, this is done by using access control lists. At their most basic level, firewalls are simply there to act as a barrier device that sits between the private and trusted internal network and the public or exposed external network known as the internet. As I said, firewalls really rely on the set of rules known as an access control list or ACL. Most of these rules are going to be based either on the destination's port and IP address or the source port and IP address, as well as the protocol type and payload. To be able to detect whether or not an organization is using a firewall, one of the easiest ways to do this is simply by running a trace route. If you do a trace route from your machine to your destination, and you see there are not responses coming back clearly, and instead you're seeing stars in the place of where those responses should be, that is indicating that there is some sort of a security device there, whether that's a firewall, a router with an ACL that's not responding back, or a unified threat management system. There are lots of different tools out there to help you map out a firewall, and one of the most common is known as Firewalk. Now, Firewalk can be used inside of Kali Linux, and you'll specify the command Firewalk, the ports you want to use, as well as the interface, and then the target. When you do this, it's going to start going through those targets on those ports to be able to start figuring out what responses it can get, and which ports are open, which ones are closed, which ones are being filtered, and more importantly, what those ACL rules might look like. Firewalk is considered an active reconnaissance tool, and its job is to try to determine what layer 4 protocols a given firewall will actually pass past it, and this helps you map out the ACL rule sets. This works by sending out either TCP or UDP packets with a time to live that is 1 hop greater than the expected targeted gateways. If the firewall or gateway allows the traffic to pass through it, it's going to forward the traffic to the next hop, and at that point, because the time to live was set at 1 hop more, it's going to respond back with an ICMP time exceeded message. Otherwise, it's going to drop that packet and there will be no response. By collecting these series of responses and non-responses, we can determine what ACL rules are in place, and then we can figure out how we can better evade that firewall or bypass that firewall during our attacks and exploits. The real benefit of using firewalking versus just doing port scanning is that you're actually trying to move through that firewall and identify what those rule sets are. This is how you can start mapping out the internal network as opposed to just the boundary device that you're seeing with the firewall when you do a regular port scan. Now, in addition to a regular firewall, we also have a specialized type of firewall called a web application firewall or layer 7 firewall. This is a specialized type of firewall that's designed to monitor web applications and prevent attacks against them. Things like SQL injections, directory traversals, and cross-site scripting attacks. Now, to detect if there's a web application firewall in place, there's a couple of key giveaways you should be looking for. Most web application firewalls will add a personalized cookie in the HTTP packets that they're sending back to somebody who's scanning them or somebody who's trying to send data through a web application firewall. By looking at those cookies in the HTTP packets, you can identify if there's a web application firewall in place. Some other web application firewalls will actually use header alteration, which changes the original response header to help confuse the attacker. So if you start seeing header responses that look abnormal, there may be a web application firewall in place. And also, sometimes the web application firewalls are just very blatant about the fact that they're there. They may send you back a page or a header that says, this site has blocked your request because it's protected by XYZ web application firewall. As far as evading these web application firewalls and getting your attacks through them, what you're going to have to do is use obfuscation to be able to confuse these devices by making it so they can't see the data as easily. As we talked about URL analysis, some of that was being done in an effort to bypass web application firewalls. Because if they're looking for something like a space, but you use %20 instead, that is a form of obfuscation that can actually get past a web application firewall, depending on how it's configured. Now, the final thing we need to talk about is antivirus. Now, antivirus is a specific type of software that's used to prevent, scan, detect, and delete viruses or malware from a computer. Once it's installed, most antivirus software will run automatically in the background to provide real-time protection against virus attacks. Now, what is the problem with antivirus? Well, when we're doing scanning, it's usually not a big deal here in the reconnaissance phase, but as we move into the attacks and exploits, it can become a real problem for us. A lot of times, the malware we're going to give as part of a spear phishing campaign or other exploit will actually be installed on the machine. But if that person has antivirus installed, it can detect that and then block it from actually running the payload, effectively killing our attack. While that's good for the company, it's not very good for us as penetration testers. So we need to find ways to bypass that and to be able to get past these antivirus systems. Now, there's a couple of ways you can do this. One is that you can create a metamorphic virus. This will actually transform the virus as it propagates around the network, and this changing pattern makes it harder for antivirus to detect. Remember, most of the effective antivirus solutions that are out there are actually based on signatures. And so if you change the signature by jumbling up the code or modifying the code, that can actually create a way for you to get past those systems. Another way to do this is by obfuscating a known signature by using specialized tools. This will actually allow you to change the code that you're doing for your exploit, similar to a metamorphic virus. Now, with a metamorphic virus, it's going to continue to change as it propagates. But when we're dealing with something like obfuscation of our own code or our own exploits, we're only doing it on a one-time basis for this particular attack. Another thing you can do is use specialized tools or payloads that use fileless malware, because a lot of operating system embedded functions can actually be used to conduct malicious activities for you. These include things like PowerShell scripts, commandlets, bash utilities, and others. These become very difficult to detect, and it's basically another form of living off the land. Another method is to use encryption. Now, by using encryption, you can effectively eliminate the ability for that antivirus program to detect the malware through using signatures alone. Now, malware authors and penetration testers will often encrypt their malicious payloads. This allows them to encrypt the file and attach a stub, which is simply a program that will decrypt the contents and execute them once they're on the victim's machine. Some common ways to execute this is by using process injection or process hollowing, which we'll talk about more when we get to attacks and exploits. As you can see, it's important to detect load balancers, firewalls, web application firewalls, and antivirus software back here in your reconnaissance and information gathering phase, because that's going to allow us to prepare for how we're going to evade them later when we get to our attacks and exploits phase.